Hi again. In this example, we have a ball is released from rest on a 750-meter building. So I'm on the top of one of these buildings. So I can sometimes sketch what I'm doing. So this is my building. I am here standing with this height. It's 750-meter above the ground. And I have an object will be released from here. The initial velocity, it's equal 0 because it says it's from rest. Now, and it's going definitely downward in this case. All right, it's asking me for the first part, how long does it take to hit the ground? So I'm trying to find the time required for this object to reach the ground, just the moment before touching the ground. Well, we keep in mind that the g, or the gravity acceleration, is still negative 9.8 meter per second squared. Now, from the kinematics equations we have, we can choose this one again. It's delta y equal the initial speed t plus half the gravity acceleration t squared. Now, let's replace these values. Now, the change in height, it's going downward, so I'll give it negative 750. The initial velocity is 0, and here is 4.8. It's half of the 9.8, and finally is the time needed for this object to hit the ground. Now, by just rearranging the equation, I will have 750 negative divided on a negative 4.8. That should give us 750 divided on 4.8. That will give us 156.25, but we are looking for the time, so we're going to put it under square root, and that should give us about 12.5 seconds. That's the time required to cover all the 750 meter and hits the ground. Okay, now for the second part, we are trying to find what is the speed of the ball just before it hits the ground, just that again moment. Now, it's looking for the v final, and I have the initial velocity plus gravity acceleration, and I know how much is the time needed to cover all that distance. So here it's 0 minus 9.8 multiplied, oops, sorry, let's fix this one. It's 9.8 multiplied by the time, which is 12.5. Now, let's do the maths. It's a 12.5 multiplied by 9.8, and that will give us 122.5 meter per second, and we definitely not gonna forget that it's negative because it's telling us the motion or this object is gaining speed but downward. That's the negative to tell us it's going downward. Okay, so here is another example related to motion vertically, but this time it's a dropped, so released from rest. It's a good idea to sketch the diagram or to help you visualizing the scenario of the question. You can label things, you can put your known things on the diagram to help you indicating what is unknown, what is missing, and from there you can pick which kinematics equation will help you solving your question. I hope you find this example useful, and see you again with another one. Thank you.